So give the heading concept of G.
Assalamu alaikum, sir.
Wa alaikum assalam. We had started in we had started dynamics 2 classes back, and we are now on a concept which is a very famous concept in our O level, and that is the concept of G. Gravitational acceleration was our concept. So give the first heading for today, concept of G. In our physics, G has two possible translations. One is called gravitational acceleration. One is called gravitational acceleration, and the second is called gravitational field strength. Now, the concept is very simple from our O level, that if we are sitting here and we are taking a class, for us, G has a meaning of gravitational field strength, signal strength. So just like a Wi-Fi signal strength, just like a case of any Bluetooth signal strength, any mobile company signal strength, gravitational field also has a signal strength that is called G. If something is falling, and it is falling freely, then G has a meaning of gravitational acceleration. So G has two possible translations. One, gravitational field strength, and second, acceleration due to gravity. So now you have to copy this screen as the first concept of today.
Done, sir.
Good. G has hence two units, Newton per kg and ms minus 2. These are the two units of G. So you have to copy these units now.
Done, sir.
Using base units, you can prove that Newton per kg is equal to ms minus 2. This is an exercise of our chapter number 1. If you recall chapter number 1, and I think 2 past paper classes on it. Look at chapter number 1. There were two main topics there. One is called base units, like the exercise you're looking at the screen now. And second, in the chapter number 1, the vector, resolution of vector was the second most important topic. Now, similarly, in kinematics, there are two important topics. One is the equation of motion, and second is the kinematic sketches, which we were discussing, I think, yesterday. So in every chapter, I do not include projectile, because I always say to my students that consider projectile as a separate chapter, because whenever projectile comes in the paper, it's a whole question on it. So now look at this screen. This is called base units. I had recently shared some tables on that also. So base unit, I consider base units, unit conversion, and estimation as a very important skill. So when you talk about base units, remember that there are 7 base units, and after that, all the other units are derived units. So now you have to copy this script.
Done, sir.
Yes, Ariba, have you done it?
Yeah.
Now, our next concept for today is friction. The symbol for friction is a small f. What is friction? Friction is a force which appears from the contact, like the shoe is on the floor. Now the contact, where the contact is there, there is a force which opposes the motion. Due to the contact between two objects, a force of opposition appears, and this force is called friction. So this is the driving force. You want to move this block. As soon as you apply the driving force, there will be a friction. There will be a friction which opposes the driving force. Now the driving force increases, so friction also increases. But if you keep on increasing the driving force, the object will eventually begin to move, and the object will accelerate. On every object, when it is moving, there is a driving force, there is weight, there is friction, and there is a reaction force, a normal reaction force, which is upward. So now we first put the definition, first copy the definition.
Done, sir.
Okay.
Done, sir.
This is the driving force, and friction comes. If you keep on increasing the driving force, friction also increases until the object begin to accelerate. Now give a side heading, force diagram, and then copy this screen.
So can you explain what is the normal reaction force again?
Normal reaction is the perpendicular reaction from a surface. So for example, you drop a ball on a surface, the ball will rebound. Why the ball will rebound? Because when you drop the ball and the ball hits the floor, the ball will exert a force on the floor. As a reaction, the floor exerts a force on the ball. That is why the ball rebounds. That reaction force is called normal reaction force. The word normal here refers to mathematics normal, which means perpendicular.
Okay.
Done, sir.
Good.
Done, sir.
The word here is normal. The word normal here is used in a sense of mathematics, and it is not used in sense of our normal English. So write under it that normal here refers to perpendicular. Second thing which is important, that R R second important thing, that R is a contact force. It appears when there is a contact. Third important thing, R is perpendicular to the surface. R is perpendicular to the surface. You have to copy this.
You can explain normal again?
Normal means perpendicular. As a word normal refers to here, as a word normal here is perpendicular. So when you drop a ball or when you throw something on any surface, like if you have leaned a ladder, here with the wall, look at the two reactions. From the wall, the reaction is coming horizontal, and from the floor, the reaction is coming vertical. So normal is just like the reaction of a surface. So when you walk barefoot on a surface, you can even feel this force. When you put your foot on the floor also exert a force back on your foot, and that is called reaction force.
Okay.
Sir.
Now you have to copy this example.
Done, sir.
Done, sir.
Good. So we made our concept. Now we move to our next heading for today: important terms in dynamics.
Sir, I asked my physics teacher about like what topics we're gonna do after unit 1. She said either we're going to do unit 2 or we're going to do waves. So like, sir, is it okay like after we do unit 2, like kinematics, we can start with waves?
What he is doing presently, can you tell me that right
She's doing
now,
she started with
important terms in dynamics? This is a topic which shows some terminologies like thinking distance, braking distance, stopping distance, and friction. In our yesterday class, we were talking about braking distance. It was a question there which was using this idea, braking distance. So now you have to copy this screen.
Okay, sir. Done, sir.
Sir.
Now give a heading, give the heading thinking distance.
Okay, sir.
What is the concept of thinking distance? Thinking distance is defined as the distance traveled by a vehicle, the distance traveled by a vehicle after the reaction of the driver. After the reaction of the driver. So suppose you're driving a vehicle and a situation appears in front of you, something came in front of you, any person is on the road or any speed breaker is there, anything, and you have to slow down or you have to apply the brakes. So during the reaction time of the driver, it is the distance traveled that is called thinking distance. So once you start driving, you will know that even an automatic vehicle or a manual vehicle, when you react as a driver, normally all good drivers or all good machines become neutral. So when you are driving a manual car, so suppose you reach a position where some people are moving on the road, so you will immediately neutral the car. Neutral means speed becomes constant, but the vehicle is moving. The distance traveled by a car between the time that a hazard is seen and this time that the brakes are applied. So this is simply called the distance travel during the reaction time of the driver. And that distance can be very large. For example, an aeroplane. An aeroplane is already traveling at such a high speed, that even if the pilot is very alert and pilot responds immediately, still the aeroplane will travel a lot of distance. So what is the concept here? The driver sees a hazard. Driver reacts.
Sir, basically it's like thinking distance is the like distance taken for like a driver to hit the brakes.
You can say that. Basically, it is the distance traveled during. It is the distance traveled during the
Reaction time, sir.
action time of the driver. Actually, hitting the brake is a perfect point. But hitting the brake is not always the choice. In many cases, steering the vehicle is also a choice. A very interesting and a very dramatic example on our media was in a movie Titanic, when they were moving and they come across an iceberg, and the captain assistant saw the iceberg, and then they react. During the reaction time in which they were running and they were thinking what to do, until they start doing something, steering, braking, lifting, drowning, anything, that is called the reaction time distance, and that is called thinking distance. So what is the concept? Whenever a hazard appears, till then, until you take an action, any action, maybe you have to accelerate, maybe you have to decelerate, maybe you have to brake, maybe you have to steer, maybe you have to maneuver like an aeroplane. That distance before you saw something and you do something, that gap distance is called thinking distance. This distance is very large for high-speed vehicles like aeroplanes, like trains. Obviously, a train pilot has not much to do. Obviously, either slowing down or braking is the option, but aeroplane have a lot of options. A car has a lot of options. So this is how we define that. Now, if you first copy this definition.
Okay, sir. Done, sir.
Done, sir.
Now copy this concept sequence.
Done, sir.
Done, sir.
During the thinking distance, speed is naturally constant. Physics always work on hypothesis, and all good students, even after A level, when they start driving or in real life, when they see things, they always think that this is not happening, because many times on a road, anything can occur, even a collision can occur, even the vehicle slips. But physics as a science has limitations. So we have assumptions, like in projectile, as we were discussing yesterday also. Projectile, we assume that air resistance is negligible. As a good student, you can think that this is a very, very bad assumption. Why? Because how can you avoid air? You play cricket, you play hockey, football, anything. Air resistance is there. Just imagine when an aeroplane is coming down, the air resistance is very strong, very strong. Aeroplane shakes. So, but the physics has a limitation because formulas are working on a ratio. Formulas cannot absorb random variables. So that is why you will see these assumptions. My assumption is here. Once you see the hazard, and if you are a good driver, whatever you are going to do, maybe you want to slow down, maybe you want to steer, maybe you want to stay what it is. You think it's a normal thing, there is nothing to worry about, let it go. So in that case, you will not react, maybe possible, but in every case, you will keep the speed constant. If it's a automatic machine, then you will just like let it to be neutral. If it's a manual machine, you make the speed constant. So this is an assumption. All vehicles do that. That is why the different pilots, different driver systems always work on that. And that is why even the automation coming now in the world, the Google driving sim, they all work on this assumption that make the speed constant. Why? Because it's better to be on a neutral side. Well, it's easy to stop a vehicle when the vehicle is at a constant speed. Accelerating vehicles are always difficult to control, and that is why an assumption is coming here. Now you have to copy this screen.
Okay, sir.
Done, sir.
Done, sir.
Thinking distance, thinking distance depends upon some feature like alertness of the driver, speed of the vehicle, and also the nature of the possible the nature of the possible accident. This is an interesting factor. Nature of the possible accident. What's the meaning of nature of the possible accident? It means that what is in coming in front of you. So suppose you do not need any worry because it's a normal thing, like a bird on the road, it will fly off, like a pet on the road, and the pet will run away. So like on a the best example is obviously coming from Dubai and those areas where motorways are high speed regions, and where stopping is always the last choice because the vehicles are going so fast, even in other countries also, that sometimes slowing down or stopping can actually make a bigger accident. For example, a train, and a train is going. So if something comes in front of it, stopping the train immediately actually will cause a bigger problem. Now you have to copy this screen. I'm just coming, copy this screen.
Done, sir.
Alertness of the driver is a very big thing. Like no way driver should be using a mobile phone, but obviously driver can be talking with the second person. So that will always divert the alertness. Alertness is something very important. So there is a human biological reaction time. That's nearly the same for everyone. But there is another physical reaction that is called alertness. For some driver, it is high. For some driver, it is low. Now give a heading, braking distance. Give the heading, braking distance. The concept is here for braking distance that you have decided that now you have to apply the brakes. So once you have decided that you have to apply the brakes, then after the application of the brakes, after pressing the brake, the vehicle will still travel some distance. The vehicle will still travel some distance, and that is called braking distance. So give the heading. The definition is there. You have to copy this.
Done, sir.
Done, sir.
Braking distance occur with uniform retardation. This is again an assumption. So once you people be driving, you will know that these assumptions never work in reality, because sometimes you have to stop abruptly, sometimes you have to stop smoothly, sometimes you are slowing down with the jerk. So there are two types of acceleration. There are two types of acceleration. One is called uniform and one is called non-uniform. So as a joke, we say that this uniform acceleration, actually it occurs only in scientists. So there is no uniform acceleration in real world. So it's not possible that you decelerate. That's fine. Some bullet trains in Japan and etc. They can exercise that. But here on our roads, anything can occur anytime. So retardation is never uniform, but it is an assumption because they want to have a straight line going down. That is possible when you have a uniform retardation, because line is a straight. Straight line means constant gradient. Okay, you have to copy this.
Done, sir.
Okay, Arima, let me know once you have done.
Done, sir.
Now, this is a straight line sketch, and look at the area which is called the braking distance. The line is a straight. Straight line means constant gradient. You have to copy this screen.
Done, sir.
So it shouldn't be retardation instead of acceleration.
Actually, the word is acceptable, but you are right to avoid confusion. We should write that because every retardation is actually an acceleration also. But I think you have a better idea because it can cause confusion in anyone because we use these terms explicitly. So I put it here and that looks better to put say, retardation here. Uniform retardation. Now shade the area and call it braking distance. If braking force remains constant, this is our next concept for today. If braking force is constant, so if braking force is constant, acceleration and mass are inversely proportional. Look at this sketch. It means we discussed it in the start of this chapter also. This is called the feature of inertia. Heavy vehicles are difficult to stop. Heavy vehicles are difficult to stop, while lighter vehicles are easy to stop. You can stop a motorcycle immediately, but a train cannot be stopped immediately. Otherwise it will slip out. Similarly, a bicycle can be stopped immediately, but a heavy vehicle like trailer, like loader, like a crane, they cannot be stopped immediately. So braking distance depends upon the braking system, the braking force. It also depends upon inertia. It depends upon the road surface and also the tire surface. So you have to copy this screen.
Done, sir.
Done, sir.
And now this screen.
Done, sir.
This is a curve and it is not touching any of the axis, not touching x-axis, not touching y-axis, because inverse proportionality is a case where it is not touching any of the two axes. Now, braking distance depends upon four important features like braking system. What type of brakes are used? This is called disc brake, which is now, I think, in bicycle and also in normal motorcycles, but it is now getting obsolete. Then the hydraulic brake system, in which we use an oil, like in heavy vehicles, it was there, but now in every vehicle, they have introduced the hydraulic system. Hydraulic system brakes are very effective, and using less force, we can stop a vehicle. Tire surface, tire should be rough, and there should be grooves on it. You can show these lines, these drains. What's the benefit of these drains or lines? They absorb any liquid on the road. Otherwise, the liquid comes between the road and the tire, and this will cause low friction, and the vehicle will slip on. It won't stop. It won't stop because even the wheels are stopped, but the vehicle will not stop because of less friction. You have to copy this.
Done, sir.
Sir, you're going to explain how like it all depends on this, yeah?
No. They're not interested in any detailing. AS level, they are not interested. They won't be asking what is hydraulic brake, what is disc brake, nothing. You just have to remember that what is braking distance. And obviously, any of these factor can change the braking distance. That is fine to remember. For example, road surface. If the road is wet, the vehicle will take more distance to apply the brakes. If the road is dry, you can stop the vehicle easily. That's all.
Okay, sir. Then.
Now give a heading, stopping distance. Stopping distance is the sum of thinking and braking distance. So if you add up them, it will be the sum. So you are driving, something comes in front of you, and you decide what you have to do, and you want to stop the vehicle. So if you are stopping the vehicle, which is not always the target, but you want to stop it, suppose, then the total distances are added. To give you the stopping distance. You have to copy this.
Okay, sir.
Done, sir.
Done, sir.
So right under it, it is the sum of thinking distance and breaking. It is the sum of the thinking distance and breaking distance. It is the sum of the thinking distance and the breaking distance. Now look at this screen that we are showing stopping and breaking. So this is a composite work and we are showing both of them. So you have to copy this screen.
Done, sir.
Done, sir.
Now give a new heading, inclined plane. Give a new heading, inclined plane. Inclined plane in simple terms, it is called a slope. Just like when a bridge starts, then you can find a slope in the start of the bridge. This is called inclined plane. So look at this slope. This is a slope. And these slopes are always there in a case when you have to take something up with less effort. So here some mathematics is coming up. This is an inclined plane. It is a slope. And there is an angle. There is an angle theta with the slope. You have to copy this screen.
Okay, sir.
Done, sir.
Done, sir.
Now I'm putting a maths concept here, which I want you people to absorb it as a maths, O-level maths. I make a triangle here. Do not change your diagram. Do not make any change in your diagram. This is the concept. This angle is 90 degree. Okay. Now suppose the theta is 30 degree. Okay. This angle is also 90 degree. Can you tell me, I shade this angle. Can you tell me what is this angle? It's
That's
a
gonna
right angle triangle.
it's gonna be 60, sir.
Okay, Ariba, what angle should be here?
60.
60, very good. Okay, now I put another question mark, double question mark. What angle this will be?
30.
Okay, and what do you say, Sam?
That's gonna be 30, sir. 30.
30. So you can see mathematically, this angle is coming here. This is our next concept for today. The theta with the x-axis will be the theta with the force, perpendicular force on the inclined plane. You have to copy this, update it actually.
Sir, didn't we already copy this?
No, you have to mark this theta. I've said update it.
Okay, okay. I'm done, sir.
Done, sir.
Now, I have resolved mg. I have resolved mg. There are two components. There are two components on mg, mg sine theta and mg cos theta. The reaction force is upward. The reaction force is upward. And this is R. R is the normal reaction. So up you can do not update the previous diagram. It will actually change the concept. Draw it on a new diagram. Draw it as a new diagram and copy this.
Okay.
Done, sir.
One second, sir.
Now I'm putting the case number 1. I have placed an object. I have placed an object on a frictionless surface. There are a number of cases in this article. This is a slope, and an object is on the slope and it is coming down. It's a frictionless inclined plane. It's a on our inclined plane, it is a free fall. So give a side heading, case number 1. And right under it, that consider an object moving, consider an object moving freely on an inclined plane. Consider an object moving freely on an inclined plane. So we keep it up to here, and we will inshallah continue this in our next class.
Okay, sir.
Allah Hafiz.
Allah Hafiz.